Okay, 81 and 82, there's not as many problems. I just noticed that. So here we go. Lesson 81. So our first one is number 1, which is a direct variation problem. So you're supposed to do it both ways. I'm going to do it both ways, just for kicks and giggles here. So we have monkeys varied directly as turtles squared. So you have to do turtle squared. This is the old way that we learned it. The first monkey mentioned was 100. We don't know the constant proportionality. We know the turtles is 2. So we're going to square it. So k is going to equal 100 divided by 4, which is 25. So we find our k, and then we go back into the original problem. Now we want to find how many monkeys there are. We have k is 25. If there are 5 YouTube video. So there's a little drag on my computer. So the monkeys are going to be 625 monkeys. Monkeys. If there's words in your problem, you should put words in your answers. All right, let's do it the other way. We're going to get the same answer. Can you believe that? Okay, I'm going to wipe this out. So the next way is you're going to do monkey 1 over monkey 2 equals turtle 1 squared over turtle 2 squared. So monkey 1, it was mentioned, was 100. We have to find the monkey 2's. The turtle 1 that was mentioned was 2. The second turtle number that was mentioned was 5. So we're just going to cross multiply. So it's going to be 25 times 100, which would be 2500, equals 4m2. And then you divide by 4, and you're going to get the number of monkeys is 625. So excuse my sloppy writing, but it's just not working. Okay, so that is how you do the first one, number 1. Number 3, we always have to have our token distance problem, right? So Roger, I'm just going to set it up. Roger made a trip that was 375 miles. So this is the distance of Roger. The distances are the same, but it's still, I know it's a little tricky. It's a separate distance problem. 375, I'm sure you could use another method to do this. And this is the distance of Judy. So this is the kind where we have the 4 equations. We're going to have distance Roger equals time Roger, rate Roger. Whoops, we should put the distance what it is. I gotta go the whole way back. So remember this one, we're gonna have 2 equations. So rate Roger, time Roger is the distance, which is 375. The rate Judy, the time Judy is equal to the distance, which is 375. And then we're going to come up with 2 other equations. We're just going to plug them in. So it took Roger 10 hours less than Judy. So we would do the time of Roger equals the time of Judy minus 10. And then it says that Roger was, this is because he traveled 3 times as fast as Judy. Wow, this is a rarity. The rate Roger equals 3 times the rate of Judy. So we're going to pick an equation to put these into. Now they're both solved for the r's. So we're going to pick this equation. We're going to put this, this is frustrating right now. We're going to put this in for the time of Roger and this in for the rate of Roger. And then that miracle happens where we have an RJ, TJ, and we put in the 375. So I'm going to leave it at that and move on. Okay, next one is number 7. So 7 is an imaginary number problem. These are actually on the SAT straight out just like this. So learn how to do these. They're not that hard. 3 minus 2i over 2i minus 4. You can't have imaginary numbers in the denominator. It's like having a radical in the denominator. So we're going to multiply the top and bottom by the conjugate, which is 2 plus 4. 2i plus 4. All right, in the numerator, it's a binomial times a binomial, so we FOIL. So we're going to get 6i. Your outer is 12. Your inner is negative 4i squared. And your last is negative 8i. Denominators are a lot easier because the outer and the inner cancel out. So we only have to do the first, which is 4i squared, and the last, which is going to be negative 16. Okay, I didn't rearrange them. I think in the book they rearrange them, but why? Why have an extra step? Okay, so now we're just going to simplify the numerator and the denominator. Now we know that this I squared is negative 1, so it's going to make this a plus. And we know that this I squared is negative 1, so it's going to make this a negative. So let's add our real numbers together. So we have 12 plus 4 is 16. Add our imaginaries, it's negative 2i. In the denominator, we just have real numbers. If we have an imaginary, we did something wrong because you're not allowed to have them. And I'm dividing everything. I'm looking how 2 goes into all these, and there's a negative on the bottom. So I'm going to divide everything by negative 2. So I'm going to get a negative 8. Plus I all over 10. And now you can simplify just a little bit further if your answer is like, you're like, whoa, I had that, but it's not with the back of the book. They separated into negative 8 over 10 plus 1/10 I. And then they took it even a step further. They reduced this, which you need to do. And you get negative 4/5 plus 1/10 I. That was your I problem. Okay, that was number, what was that? Number 7. Ooh, still got a little bit to go. Okay, 7. The next one is 17. What is that? Okay, circles. So get these down. You have to kind of memorize this every time it comes up. So you have 2 different things. You have 2 secants crisscrossing inside of a circle. Now, when you have arcs that are formed by these secants that are crossing, here's x degrees, your arcs are 40. You should learn to love these. These should become your friends. So if it crosses inside, you add them together. 40 plus 50 divided by 2. That's 90 divided by 2, which is 45. So you get x equals 45. All right, and then this one, there are tangents. There's one that's a tangent and then a secant line. Whoops, I thought I was doing a line. Oh well, bear with me. Okay, so these intersect at 140. This one is 100 degrees. And this is y degrees. And if it intersects outside, you subtract them. So 140 minus 100 divided by 2 is going to be 40 divided by 2, which is 20. So y equals 20. That's it. All right, so that was 17. Next one is 21. Did I do 7? Yes, okay, 21. Okay, I did say I was going to do one of these guys, right? One of these guys. All right, 21 this is our token one of these. I feel like we get one of these every time. So 2/3 x minus 1/3 y equals 6. And then we have 0.15x. This one's pretty easy though. 0.01y equals 0.84. We don't deal with decimals and fractions, especially not together. So either make them all the same or get rid of them. So I'm going to multiply everything in this one by 3. So we're going to get 2x minus y equals 18. And then I'm going to move the decimal point over 2 places. 15x plus y equals 84. This one you don't even have to multiply, you just add the columns. So we get 17x equals 102. Divide by 17 and we get x equals 6. Put the 6 back in maybe there. And we're going to get y equals negative 6. So your ordered pair for this is 6, negative 6. Alrighty, number 25, and that's it for this lesson. 25 is simplify. So these are always a blast. 9, and then it's going to be the 4th root of 3. So you need to make all the bases the same. So this, you got a 3. 9 can be written as 3 squared. We are also at the same time making them fractional exponents. Whatever's on the seat goes on the bottom. The radical is over this whole thing, so it's going to be all to the 1/2 power. And so we're going to get 3 And this is going to be 3 to the 9/4 to the 1/2. And then we're going to get 3 times 3 to the 9/8. And then this is to the 1 power, so we'll make it 8 over 8, so it has the same denominator. So we get 3, there goes that crazy writing again, 3 to the 17/8. And it looks like we have made it to the end. Really? Did I skip one? 21 we did, 25. Yep, okay, one more lesson then. So here we go. Lesson 82-8. Okay, circular cone has a radius of 3 meters, volume of, so the volume of it, this is number 8, the volume of a circular cone has a volume of 12 pi meters cubed, and the radius is 3 meters. So you need to know the formula for the volume of a cone. These are on the SAT as well. They give you the formula, but you should know it. So the cone is 1/3, because think of a cone, it goes like this. So it's like you're cutting off 1/3 of it. You're dividing it by 3. Pi r squared h. Pi r squared h is the volume of a cylinder. So if you had a cylinder, the volume is going to be pi, r squared h. And if you want a cone, you have to take 1/3 times it. So it tells you the volume is this. So I'm going to put the 12 pi over here. I'll throw my units on at the end. 1/3 pi r squared would be 9 times h is what we're solving for. The pi's cross out because they're on both sides. 3 goes into 9 3 times. We're just going to divide the 12 by this 3, and we get 4 equals the h, and put your units on. 4 meters is your height. All right, 22. 22, diagonal of a square. All right, I might do this a little different. So this is number 22. So we have a square. And we have a diagonal in it. And they're telling us the diagonal is, where did it go? 22. The diagonal is 6. This is going to be a 45, 45, 90 triangle. So you can work it using similar triangles, but I like to do it this way. This is x, this is x. You know they're going to be the same. It's a square. So I use the Pythagorean theorem. X squared plus x squared equals 6 squared. So we're going to get 2x squared equals 36. And we're going to get x squared equals 18. Hopefully I get this right. And take the square root of both sides. We're going to keep it positive. So it's going to be the square root of 18. And if we treat that out, or we can see that 9 times 2, so it's going to be 3 root 2. Do they have units on there? Meters, so throw your meters on there. Meters. Okay, the last one, Shannon, you asked this for the other one. I'm just feeling really like this video is too short, so I'm going to do this problem. I wasn't planning on it. So it says begin with ax squared. Of course, with more knowledge comes more accountability. So maybe you're going to have to do this in class. So we're going to derive the quadratic formula. You know the quadratic formula, right? X equals negative b plus or minus square root b squared minus 4ac over 2a. We're going to solve this for x so that we have a formula to solve any quadratic equation if you know a, b, and c. So in order to get x by itself, we have to complete the square by dividing everything by a. b over a x plus c over a equals 0. Now we're going to complete the square. X squared plus b over a x plus something equals negative c over a plus something. I'm going to divide this by 2. So where can I put that? B divided by, never mind, hold on. Yeah, BA divided by 2 is the same as 1/2, right? Multiplying by 1/2, and then we're going to square it. So we're going to get b squared over 4a. I'm going to add that to the other side. You can see how it's coming together, right? Squared. Okay. Yeah, did I do that right? Divided by 2 and square it. Okay, so now we're going to get x plus b over 2a equals, and our common denominator over here is 4a squared. And let's see. So then up here we're going to get b squared. This is going to need a 4a, right? And this is going to need a nothing. So we're going to get, I'm going to put the b squared first. So b squared minus 4ac. Look at it coming together here. Isn't that beautiful? This is squared. Now we're going to take the square root of both sides. I have a little bit more space. Square root of both sides. Let's square root u, square root u. This is all going to come out, so we're going to get x plus b over 2a equals plus or minus the square root of b squared minus 4ac, and the square root of 4a squared is 2a. Final step is I'm going to subtract the b over 2a. So I'm going to subtract that. Since the denominators are 2a, I can just, I'm going to put that under all of those. B squared, I have no more room. All over 2a. And that is the quadratic formula. So if you forget it, just derive it. Okay, I think I hit everything. Oh no, wait, 82. Yeah, I think I got it all. Did I get 25 from the last lesson? Yep, okay. So that's it for these lessons 81 and 82.